everyone. Welcome to Try Right, the new era of learning. This is Pack 365. In Module 2, we are discussing about heuristic search technique in AI. Okay, so let us discuss about heuristic search. Okay, so heuristic search technique are used for problem solving in AI systems. Those techniques help find the most efficient path from the starting point to the goal point, right? Making them essential for the application such as navigation systems, game playing, and optimization problems. So here we comes out. Heuristic search is a problem-solving technique in artificial intelligence. So that uses the rules of thumb or educated guesses, right? So to guide the search for solutions, unlike execute search methods that explores every possible path. Heuristic search prioritize like promising path, find a good or nearest optimal path solution like that more quickly and especially for the complex problems where complete search is impractical, right? So we break down that to a heuristical function. A heuristic is a function or method that estimates how close a given state is to a goal state. Okay, it provides an intelligent guesses about which direction to explore the next in the search space, right? So heuristic after offense effective but do not granted, right? So optimal solutions those prioritize speed and the flexibility of over granted perfections. Like it takes very complex, it uses complexity, speed, near optimal, adaptability. So some features it used to pick the to actually pick the goal state. We can say rapidly choose the goal state. So here we have components of the hero- heuristic search. So what are the components of the heuristic search? We have first we have state space, right? From the state space, we can say that this implies that the totality of all possible states or settings, which is considered to be a solution for the given problem, right? So here we can say that about the space search. This refers to the totally all possible states of the or settings that our problem can be in, right? Also, imagine a chess game, right? Every possible argument is of pieces on the board, right? So we can say that every arrangements of a pieces on the board represents a state. The state space is the collection of the such valid arrangements. The solution to the problem often involves the finding a path or specific state within the waste state people. So we can say like that. Initially we can conclude like this. It is a state space. So we another path we have initial state. So the initial state in the search tree of the highest level with no null values, right? It survives as the initial state of the problem hands, right? So here we can disclose it. This is the starting point of the search, right? So it is the instance of the search tree. Okay. So we can say that at the highest level, typically with the definite initial condition. So for example, in a navigation problem, the initial state would be your current location in the puzzle, right? So it's the initial configuration of your starting point. So we have another component of goal test. The exploration phases ensures whether the present state is terminal or consenting state in which the problem is solved, right? So we can here is a sum of this is a some type of crucial function that determines whether the present state is a terminal or consenting the state in which the problem is solved. It's a condition or set of conditions that when we meet signify that a solution has been found like that. For instance, in a pathfinding problem, the goal test checks if the current location is destination. In a game, it might check, right? If the player has won, like that. So success, we have successor function like this creates a situation where individual state so supplant the current state which represent the possible use or solution in the problem space, right? So this function creates a situation where the individual where the individual states supplant the current state, right, which represent the possible moves or the solution in the problem space. Essentially gives a current state. The successor function generate all the possibilities for the next state that can be reached by the applying valid actions or moves. So here we have the final component of the heuristic search, heuristic function. The function of the heuristic is the estimate the value of or value or distance from a given state, right? To the target. It helps to focus the process on the region or state that has prospected of achieving goals, right? So this is the core of heuristic search. It's the function of the heuristic is to estimate the value or distance from a given state to the target state. It helps to focus the process on the region or state that have the prospect of achieving the goals. The heuristic function does not granted to excite the cost of or distance, but provides an educated guess, a meaningful guess to guide the search toward the promising path to reach. Okay, so we have heuristic techniques here. Such techniques, we can say directly technical. Directly technical search means blind search. Directly we go to, or not always possible. The require too many time, too much memory or memory. Sorry, too much time or memory. So weak technique you can be effective if applied correctly on the right kind of tasks. Like if you have some little kind of we have weak technique like we just want to move a step like left, move, right, up, down, bottom. It has weak technique, but efficiently, if you apply the weak technique at the correct spot, it may be useful to us. So typically requirement domain specific information. So we can say here, we have an example here. We have eight puzzles. Okay. So we have a box. In that we have eight columns like of the number. So one, two, three, seven. We have unplaced number here. We have, and after that we have eight. It is also unplaced value, and four, and six, and five. Like to from this we want to put the output of the box. So we can consider here, so here we can see one, two, three. Here we have four, five. Like here we want empty, which we see empty goal. Here we want to represent the six, seven like that. So we can see in the next picture. So we want to correct the path. Like we have the same path one, two, three, four, which following the like the column circuit column. We following the circuit, right? So we have one, two, three. We have four, five. So here we have imbalance column, right? Sorry, we can say imbalance row or say imbalance cell. We call is better. So here in the cells, we have one, two, three, four, five. So okay, in the row two or in the row two and the column three, we have invalid cell, right? So to fix this invalid cell, so we have six want to move to left. We have some weak techniques like I can move six to right, so it will be fixed, right? Five six. If I for seven I will make move to down, it will be fixed, and for eight I will make move like left, like it will be form or if fill all the forms and it initial goal will be center, so it will be form a proper circle. So like the technique we use. So here we can see we have one, two, three. So we want to make the statement like this. So we have cells of eight color, eight cells. We have to make like the goal is to make the proper structure of the soul cells, and center is our goal to empty cell. So we want to find, so which is our best technique, right? We can see our left is the best technique like one, two, three, like seven. We can fill. No, our goal state is not reached. Whichever we can, we left for right technique, it is not implement. We can again we has getting some issues if we move left or right. So if right, it is possible like it is, but it is in order. But we can see here one, two, three, four, five. But eight is in a little bit unplaced. So we find. So like this, we want to choose the correct path here. So which move is best? No move is best, but because we also see eight is in place. So eight puzzle struggle. So blind search technique you use it and attributory ordering, like the priority of the operations. Heuristic search technique use makes use of the domain specific information of heuristic. What heuristic can be used to decode which eight puzzle move is the best. Okay, so what condition search? So we have here condition. For now, we just want to establish some ordering to the possible moves, right? So the value of our history. heuristic does not matter as long as it ranks to move. So later we will worry about the actual values returns by the heuristic function. So here we have again a simple puzzle of it. Number of tiles in the correct position. We have the higher the number of the better. Easy to compute, fast and take little memory. Right? We just moving left to right like that. So probably the simplest possible heuristic, where we can say a number of tiles in the incorrect position, like they can be also considered a lower bound on the number of the moves from the solution. The best move is the one of which the lowest number returns by heuristic, right? So is it heuristic more than a heuristic? Like it is always correct. Like give any two state, does it always order them properly with respect to the minimum number of the moves always for a solution? So here we can say that why we use heuristic technique means in BFS or DFS, we use level by level technique, right? So first in a BFS we use directly we reach at the top level one, level two, we increasing the level, right? We start from the level to level, we decoding the all nodes, right? So in DFS, what we do, we reach up to the depth of the tree until the empty node will be found. No neighbors will find with the no current node. So till it reaches the deep and iterative deep DFF, iterative IDDDF is also like that only. It uses the level by level, like it reaches, covers all the nodes. So it taking some little bit time complexity, right? Here we want to reach our goal state. So we're making lot of time capacity here, okay? So we're wasting. So to reduce the time complexity, so we introduce the heuristic method. Like if we have call cells or column, we can move left, right. We can reach our node. So like that, it functions will be work. So here we can see like previous goal we have. We want to the goal has make to like this, but actually no heuristic method will be perfect here, right? We have again imbalance here 8 and 2. So overcome this diagram, we use here we can do what we can do. So simply we can do here we 8 we can make up, right? We 8 is the function we are calling. For 8 we can move up, and for 6 we can move left, and for 7 we can top down. Like we can fix that goal. So another 8 puzzle heuristic. Count how many far away, how many tiles movements each title is for correct position. Some of those count over all the titles. This is another estimate on the number of the moves from all the solution. Like here we have again. So same the titles we have, we can move. Same the puzzle we can move again. So we see here we can directly we have the function. So in the case we want to each step we want to do a little function, right? Here we can easily do. Here we want to just move the 8 for left, right? For 7 we keep down, and for 8 we move left, right? Over where goal is reached. For here we can see here we performing like four like 1 second. I will explain it deeper here. So see here we performing a method like, so for 7 I want tackle for 7 I am doing down, right? So the 7 will be here. So at the time, this is my empty cell. So I'm moving 8. So I'm moving 8 to left. So my goal state, this cell will be empty. So you're performing two moves. From here, I want to do, if I want to move the 5 to here, and then I want to move 6 to here, then I want to move 7 down, then I want to move 8 left. Okay. So this performs four methods. Like we use this for four moves. Here also same situation. We used to move four moves because for 8 we want to consider up, and then we move the 6 to the right, and we move the 7 to the down, and then we move the 8 to the left, right? Then we can reach our goal state. So like this performance depends on. So it is a concept of we can easily move cell to cell. Like we can easily move, jump to the row to row, like line by. We didn't follow any line, just we moving the nodes. We can follow up the data, like we can use node by node. So how many types of heuristic search techniques we have? So for those are specific algorithms that heuristic functions to guide the search. Also, we have the technique is called a search algorithm, right? So for the pronounce it by A star, we call it A star, right? We pronounce A star search algorithm. So it is one of the most widely used and efficiently heuristic search algorithm, right? So A star finds the shortest path between the initial state and the goal state. If it is existed or if one existed, it does it does this by using the cost function often donated. So we can see that is actual cost makes by the actual cost from an initial state or the current state like that. So A star is a generator. So gradually to find the optimal path, if its heuristic function is admissible, it's never overestimates the true cost of the reaching the goal state. So second we have greedy best first search. So this algorithm always expands the nodes that appears the closest to the goal base set, right? So so solely of the heuristic function. So it has a greedy because it always takes immediate best looking options. So while often very fast and efficient in the practice, it does not guide, right? So the optimum solution it can get stuck in local optima, or we can say that take a path that or seeming good initial but turn out to be must to be low longer, like little bit longer like that. So hill climbing, hill climbing it is one of the technique, a simple iterative search algorithm that starts from the attribute solutions and tries to find a better solution by making incremental and changes of to the current state. It always moves towards a state that improves, like reduce the cost and increase the value. Like it maintain the drawback, like it that is can easily get stuck in the local optima, like that. So there's a higher peak in the hill climbing. So simulated, we can have the simulated annealing, inspired by the annealing process of maturity, heating and slowing and cooling a material to reduce the defects, right? So it is a we can say that addresses the local optima problem of the hill climbing. Instead of always moves to a better state, simulating annealing sometimes accepts the worst state with a certain possibilities, especially earlier in the search. It depends on when the temperature is high. This allows it to jump out of the local optima through. So as the temperature decreases, the probable the probability of the accepting worse moves also decreases. So it accordingly depends on the temperature. So here we have the heuristics search in AI, right? We have hill climbing and constraint and simulated and linear best first search BFS here. And we have the applications of heuristic search. So from this we have pathfinding. Pathfinding is nothing but navigating the city or GPA, like we are traveling in a distance and we're finding the path to path like directions. Here A star search is also particularly proper for this application. Like we are finding the distance between two nodes or two objects like that. We are a path for direct finding the route better and shortest route for to go between those paths. So optimization from resource allocated to scheduling heuristic method helps make the most of the available resources while maximizing the efficiency, right? So from resource allocation, task or to employees or machines to scheduling the flight schedules like the right, production schedules, heuristic methods helps make the most available resource while making efficiency, right? They are used to find the good solutions. So game playing, it is a strategy game like chess and Go, right? Relies on the heuristic search to the evaluate the possible moves and the plan ahead. So in this strategy game like chess and Go, AI really uh, relies on the heuristic search to evaluate, right? So since the number of the possibility moves such in a game, heuristic function are used to estimate the goodness of the position allowing to AI, right? So it alpha beta pruning often incorporated so so it depends on the mostly moving the positions, changing the position. Like in the chess, we can conclude that each and every like each and every cell has a specific method to follow, and each and every soldier has in its own ability, right? So king has one ability, and prime has one ability, and elephant has one ability to move directions. For horse, we have one ability to make for L directions. Like that, we have two each and every head. There is specific directions. It has its own strategy of the game. So robotics, automation robotics uses the heuristic search. Yes, search algorithm. Here we can say automated robots uses the heuristic search to determine those movements, avoid the obstacles, and the complete task efficiently. Right. So this includes the navigation in unknown environment, a robot arms control, and the planning complex sequence of the action. Right. So it makes the real-time decisions and dynamic environment. So in last and final, we have the applications of heuristic and of NLP, natural language processing. So such algorithm plays a key role in the language processing tasks like parsing, semantic analysis, and text generation, helping AI understand the generate language. So here we see the language NLP tasks like parsing, analyzing, and the grammatic structure of the sentence semantic analysis. So understanding the meaning of the text and the text generation created human-like text. So here understand and the generating human language by efficiently exploring possibilities and the interpretation or combination of the words and passes. For the example, find the most probable place like trees or for the sentence. So like that we have the sentiment analysis. We also know about sentiment analysis. It is generating the reviews on the based on the multiple statements were given by the clients or users. So finally, outcome of this is a part of the heuristic search. So I hope you guys already understand about the topic of the heuristic search. Let's meet in the next lecture. Until then, thank you.